Hello and welcome everyone. We're really happy to have you here today for our weekly OCI deep dive. For those of you that might be new to these events, we're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. I'll be sharing some resources throughout that will lead you back to those forums. And if you're not already a member, we invite you to create a free account, join in discussions, look for upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today I'm glad to have Avi Huber, Senior Director of Product Management with us, along with Tim Mooney, Senior Principal Product Marketing Director, for a deep dive into how OCI APM can help you proactively monitor your cloud-native apps. All right, I think that is quite enough from me. So Tim, Avi, it is all yours. Go ahead and take it away.
All right, great. Thanks, Kenna. And I want to make one more introduction. We got Jürgen Lear here with us today. He's the product manager, and it's his birthday. So happy birthday to you, Jürgen. Thanks for joining us. And again, our topic today is proactive monitoring for cloud-native apps. We'll talk about what we mean by proactive. And so our agenda, I'll start out with just a little orientation on our observability and management platform. I'll turn it over to Avi, who will go into APM. We'll show you a demo. Jürgen will do the demo, which is a great way to really see what this is all about. And then we'll have a couple more slides, and we have some dedicated time planned at the end of the session. And throughout the entire session, use that Q&A panel. This really is for you. We designed this to be interactive, so we really want you to participate with us. You've got experts on the line to answer your questions in real time. We also, as Kenna mentioned, we have some resources. Kenna is probably going to pop those into chat, so you'll have the links, and we will provide the slides and so on after the session within about a day. All right, next slide. So just a little orientation. We're talking about an OCI service here, application performance monitoring. One of the beauties of the platform is it's built into Oracle Cloud infrastructure. What that means is you're leveraging the compute, the storage, the network, and all the security of OCI. Then built on top of that and integrated to OCI is what we call the O&M, or Observability and Management Foundational Services, logging, monitoring, alarms, and so on. This is a pretty rich feature set, and I'll call this the free tier or almost free. A lot of great services here that are leveraged by those super high value services that I'm showing across the top. Logging analytics, database management, APM, which we'll be talking about today, capacity planning, and SQL Insights. These services leverage some huge features like machine learning, some great graphics and analytics representations. You'll see how these things work. The beauty, one of the nice features of this platform is all of these services are integrated together. And what that means is, for example, in APM, you can be monitoring your apps. If you run into some issue, you want to look at the logs, you can jump over to logging analytics and look in context of where you left off with APM. There's no context switching for different types of applications and so on. It's very seamless and is really nice for workflow. So that's our platform as a whole. We're going to talk about APM. And with that, Avi, I'm going to turn it over to you.
Thank you, Tim. Let me take the slide forward. There you go. So a quick overview of APM. The service, this is a brand new service, and if you're familiar with our what we call Gen 1 service, OMC, this is not a copy of it or a simple evolution of it. We started the service from scratch and build it with utilizing open standard, and mainly, or in the heart of it, we implemented the distributed tracing service. I'll explain a little bit more what distributed service is, in case some people are still not up to speed on that in the next slide. The thing to remember, this is our new way to achieve APM. So we are doing APM by adopting and implementing distributed tracing, which works great for any new applications being developed using microservices, but also covers all the older type of application using SOA and Java, J2E, heavier J2E applications, and as well as things that are not Java at all. The second component of APM is real user monitoring. This is also relying on distributed tracing. Distributed tracing covers all part of the application, including the front end of the application, the browser or the mobile app that is being used. And we'll talk more about that as well. Synthetic monitoring, this is the portion, the monitors that runs and tests your application. You record a script, or maybe you write utilizing an API to write JavaScript to call REST services, and you run it from many locations every few minutes, run it again and again and again. As soon as something goes wrong in your application, that script will fail. This is the first notice that you will have that something goes wrong.
So Avi, if I can interrupt just for one quick second, I think this is partly what we're referring to when we say proactive, meaning you can run this script ahead of any transactions happening from, I'll say, real customers. So now you're getting a look at how the system reacts to a given workload.
Yeah, absolutely. The most kind of common or obvious way to see it is you update your application at midnight because it's a new version when you don't have any users. 5 minutes later, the script starts to fail because something went wrong, or you there is some network issue on your data center somewhere, and a portion of the world doesn't see your application. Your network, your monitors will fail early enough. And it's also if something else goes wrong, a server dropped out, and it so happens that this the other server that is the backup that is not really taking the traffic, your monitor will see it. It's an excellent way to know what's going on very early on the process. Continue on the last portion of this server monitoring. We are running on servers, and whether they are Java servers, WebLogic, newer servers running Netty, or maybe Helidon, and so on. We want to collect metrics from them to know ahead of time. It's also a portion of the proactive monitoring. I want to collect the memory utilization, and if it's going up, assume that it will eventually get to somewhere that it will crash and give you an alert on that. So we give you capabilities that are based on our own collections, as well as open through open telemetry again. Let me move on and get a little bit more detailed here. And this is under 60 seconds on, how open tracing or how distributed tracing works. So very quickly, the idea here is to collect activities or collect records of actions from each one of the components and to synchronize this component. So this is example of applications starting with a browser, microservices, and go to the database, kind of standard application, but none of these components is mandatory here. It may be application that is a single server that makes calls within it, or maybe it's some API opened and the backend is actually a call to another service. The idea is this: you start a call, and I'll talk about it with this context of the browser. So the browser says that there is an agent in the browser or tracer on the browser that says an AJAX call is happening. So this thing on the browser add to the headers of this HTTP call, and that might be a different type of call, but the standard is HTTP call, add a trace ID and span ID. Trace ID is a 2 Unix number. The second application picks it up and says, let's say that this is Java that executes the servlets. The servlet will say, oh, I have a trace ID here. And I'll keep this trace ID. I'm creating another span ID and send him on the header on the next call, and so on. The last call says, I'm returning now. The call ended, the Java call was executed. Maybe there was an SQL there that was executed. Looking at the trace and says, okay, this call took 20 seconds, and I'm sending the information about this call back to our service, to the distributed tracing service. This is APM in our case. So I'm sending the trace ID and the span ID from each one of these, including some spans on the SQL. I can send many more spans. And each one of these spans, these are the things that I'm sending, contains a lot of information. It can contain the name of the microservice it's running on, the host that it's running on. It contains the time, the number of errors that came up, any information that I want to add. When all of this data comes together to the service can say, now I can aggregate this by trace ID, and I have the full flow. Now, collecting all of this for each one of the events gives you a full tracing capability on your application. And this is exactly what APM is doing.
Okay, let's run our here. Yeah. This is our first survey on the topic on distributed tracing. So what distributed tracing systems are you folks using today? Oracle APM, Zipkin, Jaeger, other cloud services, or none? And then which programming languages are you using? Yeah, I think this is getting more and more important to have distributed tracing capabilities, Avi. And although what I'm seeing so far in the poll is we're early on for some folks.
Yeah. So maybe while we are waiting for the service, I'll say this. The distributed tracing started because companies like it started with Twitter and Uber. Actually, it has some earlier references. Couldn't manage their microservices-based application. They just couldn't use the existing tools to follow on application that contains a lot of server distributed applications.
Good history. All right, I'm going to give them 5 seconds, 4 seconds to finish the poll. I'll share the results, and then I'll let you continue, Ivy. So there you have it. 75% of our audience is not using distributed tracing yet. APM is being used, Jaeger is being used, and then the vast majority, 67%, are using Java in their programming languages. All right, thanks, people. Go ahead, Avi.
Yeah. All right. So how does APM implement distributed service, distributed tracing, and what does it really mean? So I said earlier, and I'll try to explain how the product works from that perspective. So we said that every component is sending all the actions. So there would be some, if you are looking at more earlier distributed tracing, and actually many of the APM vendors that adopt this today, they are not built for high volumes. The traditional APM service will aggregate data on the agent and send data on the aggregate data out. We build a service from scratch to be able to address, to be able to accept any volume that you may have. We still support sampling if required, so you don't have to send everything, but the product is built to send all the data because we believe this is where the value is. You upload all your spans, every instance of every invocation in order to be able to do analytics on it, to analyze, to debug, to analyze, to get the information on it later on. So the second portion is open tracing and open telemetry. It started with something called open tracing, which is an open standard, and that matured to open telemetry, which becomes very popular now. and you will see OpenTelemetry tracers. These are the things that collects the data, and I'll explain about it a bit later, for hundreds of type of applications and languages, and it's an open standard that you can easily extend it to support whatever it is that you need. I talked about it, that we are collecting all the data. It's not enough just to collect the data. We also want to have it in the database stored so you can analyze it. You can look at the performance that you have today and compare it to the performance of the application 3 months ago when you maybe didn't have this new problem that you just discovered. Or how does it work today when you have 2,000 users compared to the times that it had only 1,000 users, and so on. The way to look at this data, we built a language which is somewhat similar to SQL, but it's very open tracing or fit to this notion of having spans and traces, and allows you to aggregate the data, filter the data. So show me all the data by aggregate all the spans that are failing and aggregate it by locations. See if you have more problems with people who are calling from Holland comparing to people who are calling from South Africa. Of course, nice UI, we have a lot of data, and we built there's a visualization for traces, both as a topology, as a time Gantt, is an ability to put this together on a dashboard that you can customize and build for different function on the organization. I'll talk about Apdex a bit later on. It's the ability in more detail, but basically this is an important capability that allows you to get one number, eventually it tells you how well you're doing in any component that you look for. I'll get into this a bit later on. And the last portion, it is actually very important, and it's not obvious, and it's not available for many of the other open source services, distributed tracing applications that are available. We are collecting a lot of data. You can add, for example, the time that it takes to run an operation, or maybe time taken to execute the number of errors that happens. But you can add other metrics. I can add, for example, capture from a browser the cart value that is being executed. I can use any of these numbers and create a metric out of them that I can alert on. So I can, for example, say, well, look at all defined metrics that says if a SQL is running slow, it's an insert SQL into this table, a specific table in the database, because that's how our application works and it's important for me. I can make a metrics out of the performance of this one single SQL in the condition that I care about, let's say only in my production environment and only when the data, the customer is of a certain type, and make a metric out of that, and also calculate, analyze a anomaly on this metric, so you can get an alert if the data is anomalous or went over a certain time, and so on. Very quickly, I'm not going to spend much time on this, but explaining how do we collect the data. So I'll start here on this bracket over here. We are collecting, we support OpenTelemetry. So you can use OpenTelemetry tracers, whatever the tracer are. We support the Zipkin format. This is the wire format that we are collecting. So you can configure it to send the data to us. If you're running on a Java application, we also have our own tracer dedicated for Java, which means rather than using one of these open ones, use our tracer, you'll get some additional information. I talked earlier about the fact that we are collecting what data you're getting from each one of the components. If you're running our tracer out of the box, we collect a lot more data that we think is relevant. If you're running on OCI, for example, we'll collect the compute name, we'll collect the OKE cluster version, the compartment it's running on. If you're running on Kubernetes, even if it's not in OK, you may want the node ID of the node IP address that the specific compute is running on, and so on. Actually, we also have some deep dive capabilities that I'll get to at the end if I'll have time. The last portion of the option here is actually running our agent versus our tracer. Our agent is the same tracer, using the same tracer, but it also has automatic instrumentation. So if your application is older than the newest deployments of service, so it's not Helidon, it's WebLogic. There is no support, built-in support for open tracing. Our probes use bytecode instrumentation. This is a piece of code that are part of the agent, and they create these spans that then send out through the tracers. Of course, we support, as I said, we have a browser agent that sends the data, and we support an open API that we internally use it, for example, a Fusion a function as a service, for example, you check a flag and it will send a span to our service. I mentioned earlier that we are utilizing the same strategy for real user monitoring. This is how we collect the data. So we collect the data from a browser using a browser agent, which is a JavaScript that run on your browser. You can get the JavaScript by adding it to the application. So if you're running a React or Angular, you will just add it to your HTML index.html. But if it's maybe an older application that's running JSP, our agent, our Java agent, will insert it automatically. And once the JavaScript is there, and this JavaScript is similar to Google Analytics from functionality-wise, but it's actually much richer from the perspective of APM. Once you click on a button, click on something on the UI that makes an action, it will create a span, add the context, the trace ID and the span ID into the HTTP request, and when the operation ends, send the operation back to us. The data that we are collecting include things like the browser type that you're running on, the location that it's being executed from, how long it took to get the response for the AJAX call, and so on. Important, very important here, and that was true for the Java agent as well, is the out-of-the-box dimension that I said that we are collecting that gives all this richness, but also the customized dimension and metrics. And I mentioned that earlier too. This is the critical thing, that you can add anything that you want here. If your application is important, is this user using some portion of the application or another, you add it to the JavaScript and set it and have it as part of each one of these actions, of each one of these spans. Say, oh, I'm running on version 2 of the application right now, or I'm collecting some metrics that says, for example, what I said earlier, the metrics of the cart value. Moving on here, I think we can do a quick demo. Let's say
today we'll start our demo from the APM homepage. I selected APM home, and it gives you, as a proper dashboard, an overview of a couple of things. For instance, we have a widget here on the alarms that are firing currently. We have something on traces, monitors, which we're going into in a minute, app servers, and the services that are part of your application environment. It gives you a service topology, and it provides some data on real user data metrics. The real user data metrics are gathered by implementing a small JavaScript widget, piece of JavaScript into your application, so that it sends off data when people open pages within your application or do navigations or click within a particular page to open up certain pieces of information within the page. This is all displayed in a generic dashboard framework like this, and we have on the back end an interactive UI that allows you to interact with the data, which is called Trace Explorer. So I clicked on it, and now it opened the same view, but then in a larger view where I can do all kinds of filtering and selections. The easiest way to do a selection here is by changing the metric. For instance, when I'm not interested in the number of web applications, but I'm interested in, for instance, the max duration, I can look into this, and the map is updated with the amount of durations per location. I can drill down on a location by just clicking on it, and it drills down to the next level of information, to the regions. For US, that's states. For other countries, that's regions, like in Europe, for instance, or in Asia. Switching gears, I can see this information by geolocation, but I can also see it by user. So if you have an application that allows you to log in, for instance, then you can see all the users that were using your application by name, have the individual Apdex values for their usage. And I actually did a small session on the target application before I started this demo, and it looks like my session has been captured. If I look at this, I can look at the individual session of that user, in this case myself. If I select it to be in a chronological order, then I can see my entire session, starting from opening up the wine store, doing a partial update by clicking on a particular product. It puts it into the cart, and then I want to confirm my order, so basically do an order, and it shows back as confirmed. Now, within all these clicks and within all these navigations, I do see there are different timings involved. For instance, when I want to confirm my order, it takes 4 seconds to complete. That might be a long time, something that you want to improve on. I also see that there's 15 spans with that navigation involved, so 15 individual jobs that are done on the back end of your application. And by just clicking on this particular link, it shows me the topology. So what services within your application were called to give me the reply to get the order confirmed. I can see by the width of the arrows how long it took, or whether it took a longer or shorter, in a topology overview. I also have the Gantt chart below explaining the same thing. So now I can see that I do the confirmation call. It took 4.2 seconds to complete, and it goes through a number of different services. So it goes to order confirmed as a service, and that has to go to the payments service. It verifies the payment, and it basically comes back in 1.5 seconds. So why did it take 4.2 seconds? Well, after this, it makes a call into an ad service. The ad service is not really needed to get your confirmation, so this might be an improvement that you want to look into. So we've just been going through a very simple overview, a very simple setup, where we've shown what we can do on a particular user basis. Now, if I want to get a more holistic overview of all the users, I can use another dashboard, which is particularly geared towards the real user monitoring, so everything related to all the users. If I click on that one, it opens up a new screen, and it gives me all the data for all the real users of your application. And it doesn't only display that by the geolocation as we've seen on the previous dashboard, but now it gives me a lot of additional details.
All right, Jürgen, let's stop here and move along. I think we have quite a lot of things to cover. So we talked about the ability, how we collect the data using open tracing or distributed tracing, and how we're using it for real user monitoring. And I think in case it was not obvious, the data that we see everywhere is based on this query language. So when you click on a button there to see, Jürgen clicked on the user button, we saw the list of users. That means that the query, it's kind of a quick search to save the query content, the text of the query that will bring the right data. If you write the query differently, you see it as a topology view and present it as a topology view, or as a table, or as a Gantt chart, or etc. So let me go on and explain a little bit about synthetic monitoring. I mentioned it earlier, a very important part of the proactive monitoring. So we can run a synthetic script, either it's as a Selenium script that represent a full browser session, or a set of actions that you can record and run again. But it can be also a simple page load. I want to test that my application, the home page is loading all the time. The login page is loading all the time. As well as testing something that is farther in using a REST API or a JavaScript. If I want to call one REST API based on the result, I want to use some JavaScript to call the next REST API, which will be actually what is relevant to test many of the microservices that we see. So you can run each one of these 4, and in most applications, you run all 4 of them. You'll run some tests that are script for the browser application, but then you definitely want every minute to ping up to make sure that the page is still loading. And then every few minutes you want to run to test that your APIs. We are when we run a script, we collect when you run a browser script. So the first 2, we are executing a browser. It's actually a headless browser running on our server somewhere, but it is a browser that's running. So we can collect the HAR file from it. That includes all the information about this execution. So you will see, and this is what you see on the screenshot here, the details of the loading of each one of the little components on the page. Which one took longer, which one took faster, which one fell, and so on. Where you are running this script from, so we provide vantage points, location from which you would run it. So when you define the monitor, you can select, I want to run this from Australia, South America, the East Coast, the West Coast in the US, etc. We allow you to run it from any data center that we have. So you can run and select to run it from all of them or from some of them based on your needs, where your customers are coming from. And actually, starting today, we are also allowing you to run it from within your network, from within your data center. And I'll talk a little about it later in more detail. These are the private vantage point that you see here. Important thing is that when you're running a script, either whichever of these option of the browser, if assuming that your application is also monitored, although you can work independently, your application is likely to be monitored by APM as well. We have the idea of this monitor running as part of one of the dimension on the spans that we talked about earlier. So if there is a slowness on the performance here, you can drill down to see exactly which server, where down the line of the application the problem is. Drill down directly in context to the execution of the backend. And of course, all the data is available for alerting. That's the most, what's the more critical things that you want to have. You have this alert that says, well, if more than 2 of my tests are failing within a 5 minutes period, I want to know about it. Obviously, something is wrong. Let's do the next survey, Tim.
Yeah, okay. So go ahead and fill out this survey. What type of synthetic monitoring are you using today? And if you aren't using any, you can put none. So
synthetic monitoring and ability to monitor from a bit history on that as well. I was working in a company named Mercury Interactive, later acquired by HP 20 years ago. It was already being deemed as critical as a way to know that your application is running. And most of organizations will have this, even if you don't know about it. In Oracle, we of course using it heavily to monitor everything inside our IT operation, all our software as a service. Everybody is actually in the process of moving to use APM right now. We soon will have tens of thousands of services that will be monitored internally by Oracle by this service.
Cool. All right. So we got a bunch of answers, and I am going to end the poll and share the results here. And not unlike our previous poll, there's a number of users that are not using synthetic monitoring yet. So yeah, let's turn it back to you, Avi.
Okay, so let's do another quick demo and show synthetic monitoring, what it looks like.
For synthetic functionality, I'll be going to a dashboard which is dedicated for the synthetic functionality as well, overview of monitors. Right here, I'm showing all the monitors that are being executed on behalf of my APM domain. I'm seeing all the runs, where they fail, in what time frame they fail, and from which vantage point. And vantage point is just a location from which you want to run your monitor from. Where they fail and how much they fail. If you have a problem in a particular vantage point, it might be subject to something like a communication or a connection issue. Overall, if your application is misbehaving, I'm expecting all of these vantage points to fire at the same time, because then the application is no longer available. It gives you information about load time, connection, load time breakdown. Like, are you using most of the time on JavaScript or Ajax calls? And then you've got the individual runs for a particular monitor. Let's look into one of them, the wine store EE. It now takes me to a page which tells me something about the monitor itself. In this case, it's a scripted browser. It runs from a number of locations, and each and every location, like Sydney here, where I'm seeing 27 seconds for an execution, while the others are taking like roughly 10, 11 seconds. So that might be one where I want to look into. If I want to look into it, I can use it to use the view trace details. That takes me to Trace Explorer and the same kind of functionality that we had before. So what I want to do is look at it from a browser perspective, which is HTTP archive file, the HAR file. If I look at that, it opens up a view of everything that happened in the browser. So I'm executing this this monitor. It goes through the same type of application. So it tries to buy something from the wine store. I'm seeing here that there's like 16.8 seconds being wasted on this particular call at all. So it's a post checkout, and it's again the checkout confirmation file, which is taking a very long time. Each and every step that we're doing within the monitor, we have a screenshot for, so you can see what actually is being done. This is that confirm order view of the particular step in the transaction. You can see exactly where time is being spent, where it's being spent on. If I click on post checkout, it actually gives me additional information about what happened in terms of request, response, the cookies, and the timings.
Thank you, Jorgen. I mentioned earlier that today we are releasing the option for dedicated vantage points. This is the ability to run, rather than from some public internet, not some, from the Oracle, from the public vantage points that are available on all of Oracle clouds, but actually lives on the internet, meaning they ping something that is available to anybody to see, right? Your external web page. This one, you can use exactly the same technology and run it within your data center. So the way we run it is it's a Kubernetes cloud running on OCI. So it's using our tenant for the public vantage point. But what we are provided here is ability to deploy this in your tenant, meaning there's using stack the stack capabilities of crowd of OCI. So you select the template that we put in, added as of today to the stack capability in OCI. you execute it, and what you'll end up with is a small cluster of OKE, of Kubernetes, running and having and hosting this application. The value here, of course, first, it gives you ability to monitor whatever you're running internally. So if you have maybe you don't even have an outside application, you want to run it internally. Maybe you want to monitor separately some of the REST services that are running inside and don't have access from the internet, which is likely, right? I'm running testing some APIs that are implemented on the second, third, and fourth tier of my application. The fact that it's running on your tenant means that you can use it with your own VCN. So whatever configuration you have on your VCN will work here. If your VCN is actually connected to your on-premise data center through VPN, then you can monitor your on-premise data center through this as well. If you want to have the data connected through VPN to some external location somewhere, running, I don't know where, some other third-party cloud, maybe on Azure using the connection that Oracle has, the Fast Connect, that works as well. Basically, that gives you full capabilities to monitor anything that you have access to within your tenant.
Great, Avi. This looks like a great new feature.
Yeah, absolutely. I think we actually were hoping to get it a bit earlier. It's actually interesting. Security in OCI is such that every process that we do requires several layers of committees and approvals, which took us more than we expected. But today it's on, so everybody is ready to use it. By the way, the time that takes you from zero, right? Let's say that I don't know how long it takes to create a tenant in OCI, but once you have a tenant, to go to APM and to get something monitoring is a few minutes, basically. If it's the first time that you're looking at this, it's still under an hour to get something to run, to test your application, to get 24/7 multiple locations testing of your application with the Vantage point. I'm not going to spend too much time here. I think we are about to run out of time on metric collection. This is critical. You may kind of think about it. This is a basic capabilities, right? I'm running on a JVM on the app server. I'm collecting data from the app server, and I need to have a dashboard to show it. By the way, this is an out-of-the-box dashboard that we have on the screenshot, but you can customize and create this dashboard any way you want them. Each one of these widgets is a component that can be drag and dropped and added to filters and so on. So I'm looking at the specific application here in the screenshot, app server, and collecting important information, if usage, a metric. This data in this example was collected with the JMX because it's standard web logic application, and we're running the Java server on it. But if your application might be something completely different, it may be a Node.js application, maybe it's a .NET application, maybe it's something that we never heard about it before. Through OpenTelemetry, which is the second leg of OpenTelemetry, is monitoring, is metrics. The first leg was tracing. The third leg is logging, that I'm not talking about this today. But the second, we are supporting this, of course, through our logging analytics service. But the second leg is metrics, which are collected, and the standard is Prometheus. So if you look at the Prometheus exporter, you will see that you can run Prometheus on practically anything that you may think about. And if you have something that exposes metrics for Prometheus, rather than collecting them into Prometheus, we can collect them directly to OCI using the monitoring service. So the data is being collected by either by our Java agent or by a management agent, a generic agent that sits either on a specific host or maybe calling it remotely. It's an HTTP request into the host/metrics, and it collects the metrics, and the metrics are available for you now for dashboarding, for alerting, for presentations, even for exporting it to see it on other dashboard like Grafana. The important thing is everything is configurable. So we are collecting about 30 different metrics out of WebLogic of a JVM, another 20 for WebLogic, and you may have another 200 that you want to collect, and there's no reason not to collect them. So going on, I mentioned earlier, I talked about Apdex, and very quickly, Jorgen mentioned it too in the demo. Apdex is a kind of small thing that is extremely powerful. You are looking at an application, and you may have any number of component weight. Let's take it very simple. Your application, you do log in, and you can update your address, and you may also on the same application run a report. So the login takes about 2 to 3 seconds. That's the normal work for it. Your update of the address takes about 20 milliseconds, and the running the report takes about 60 seconds. This is your application. So you want to know that your application is okay, right? This is what you do monitoring. Is my application good now? So what does that mean? Well, I see that I can do all 3 applications because I have monitor for the 3 options and all of them works. That's great. But how long does it take? If the report, instead of running 60 seconds, running 2 minutes, obviously, that's not good. Something is bad. If it's running 20 minutes, it's even worse. The login, if it moved from 3 seconds to 5 seconds, this is really bad for me because I have a million users that logging in, each one of them taking another 2 minutes, they actually go to the competition. So if I have 3 options, I need to say, well, I have 3 things and all of them are running fine, or all of them are 2 of them running fine right now, but my update address moved from 20 milliseconds to 50 milliseconds. It's not okay. Now, of course, in your application, you don't have 3 things, you have 300 things like that. Each one has its own timing. How do I do it together? How can I say that my application is good or not good right now? Is it working fast enough or not? Apdex allows you to get this and put these 3 different numbers that I talk about, the 60 seconds, the 15 milliseconds, and the 3 seconds together into one scale, a scale from 0 to 1. So you can define a rule that says for this type of operation, good means under 20 seconds, and great means under 15 milliseconds. And for that other operation, good means under 60 seconds, and great means under 45 seconds. Using these 2 metrics for any component allows you to have score for each one of these between 0 and 1, and then I can average this together and have a total score for my entire application. In this case, right, my score is 0.7. And I can see that 9.6% of the calls that I had here were frustrated. We suggest this is kind of bad, depending on where you're using it. Originally, it was used only for user interface, active action on the UI, but we actually extended it to be used for any component. So I can define Apdex on my calls to a third-party REST service or to SQLs and so on.
Hey, Avi, just to interrupt for a quick second here. I find this to be sort of indicative of APM as a whole, where you want a quick snapshot of your entire environment, for example, your key applications. You can take a quick look and see how your Apdex is doing, compare it to how you've been normally. And although it doesn't show you a lot of data, it gives you that quick understanding of how you stand compared to where you were. And if you want further detail, if something's happening, you want to investigate the frustrated users, you can double click, so to speak, and find out that level of detail. So this is a cool feature.
Yeah, exactly. So exactly as you said it, you look at the Apdex and say, oh, I have 0.7 for my application. But then you say, well, so for my 4 services, which of the Apdex for each one of these 4 services? I can group it down by services and see 3 of my services I'm on 0.9 and 1 service is on 0.7. I'm drilling down on that 1 service. Is it on the the slowness is related to SQL or not. I can keep on going on the Apdex, and then eventually goes to say, well, look at the actual operation. Because of course, as you remember, we are collecting all the operations. You can see each one of them and aggregate each one in each combination that you want.
Cool.
Very powerful feature. Actually, before I go to thread snapshot, I wanted to mention something else here it's somewhat related to Apdex, and I mentioned it very briefly earlier. I think it's important to get a little bit more of this. How we calculate the Apdex is by when a span, if you remember, span is the operation, data about operation comes in. We set a rule. You see the rule here on the side. In this case, it says if the scan, this is the dimension, kind equals server, and the service name equal, it's actually a name of a function. Then set this, these are the Apdex rules that you want to set. We actually set other ability things that we can do at the time that the span comes in. I mentioned earlier that we can create custom metrics. So I can say, for example, using this same type of pattern and says, oh, and take the duration of this condition and make a metric out of this. So as data comes in, flows into the service, before even it's go to the database, we automatically can do some operation on that and make it a metric that is available on the monitoring service, available for alerting, available for machine learning. So actually every metric that we also enable automatic anomaly detection on it. So I can set for this set of rules that I know that I have problems there. I set an Apdex to see the high volume, but I also set a metrics that I can see how this is a specific thing behaved over time. All right, I see.
All right, Avi, we've got about 5 minutes left, so I do want to leave a couple of minutes at the end for dedicated Q&A. So just a heads up.
All right, no. So it's 5 minutes left. So let's say I'll skip the thread snapshot operation, and it will be on the slide, and we'll probably find that there's some other materials that present this on the next slide. So let's go to the Q&A.
Okay, great. So yeah, fantastic. Love the demos. Thank you, Jürgen. Again, happy birthday. Avi, great explanation of the service. I'm sharing these resources while we do some dedicated Q&A time. So those in the audience, this is a great opportunity for you to shoot any questions you have to our experts. I'll walk through some of these resources and we can talk to any of your questions along the way. Let's see. One question that I'm seeing, Avi or Jürgen, can I use APM to monitor mobile apps?
Yeah, absolutely. So there's actually two sides of it. For mobile apps, data to come from mobiles, you may run something that is running within a browser. And then, of course, the Java, the browser agent works as usual. But let's say that you have a native mobile app, something running built in Swift. Do I monitor the backend? Of course, what happens when this Swift application called the backend? But maybe I want to have information directly from the Swift application. There is an OpenTelemetry tracer for Swift. You go to GitHub, search for OpenTelemetry Swift, and you find it, and you embed it into your application. There's an instruction. Of course, it's a part of the build of the application in that case. And from you configure it to send the data to APM, and you have a solution monitoring for Swift. Similar works for Android. Actually, our own Java agent can run on Android, but there's our lighter weight OpenTelemetry traces dedicated for that.
Hey, Avi, we had an earlier question about deployment or how the deployment looks in regards to the architecture. Do any of these resources point to some details that our audience can refer to understand typical deployment?
Yeah. Great question. So actually, we have Yutaka, who is also on our call here, created 3 live labs. If you're not familiar with live labs, it's you can go livelab.oracle.com, I think. And if you search for application performance monitoring, you'll find 3 different live labs that take you to 3 steps of levels of deployment. One is a very simple one to use traces on Helidon. And the third one is how do you go and deploy this on application that runs on Kubernetes. In the example, it will be a WebLogic running on Kubernetes on OKE, but actually it will work for any application running on OKE. There's actually a couple of YouTubes in tutorial in documents that shows you how to deploy it on a Tomcat application. You will get the deployment. If you're using our Java agent, is pretty trivial, and you will get the point by looking at these videos. It applies to some examples, but it covers to other examples as well. So, for example, there's a question how you do this on Python. Python is a scripting language. OpenTelemetry is available, and we have several blogs here and tutorials that shows you how to do that.
Great, thanks, Avi. I just sent out the link to Live Labs on the chat, so please take a look at that. And I just want to note to everyone that check us out on the blogs. I'll shoot out a blog here just so you can find us there. You can find a lot of these resources through that, and you will receive a copy of this presentation with all these live links, so you can refer back to these then as well. Okay, we're at the top of the hour. I'm going to give it a couple more seconds. If anybody else has any questions, we do have one last poll as well. So on a scale of 1 to 10, how likely are you to recommend this webinar to colleagues? I'm going to take a second to thank Jürgen, Yutaka, and Avi for their presentations today. Kenna, thanks for hosting us. And everybody have a great day. Thanks for filling out the polls.
Thanks, everybody. Appreciate your feedback on the polls, and we'll see you next time for future events on Cloud Customer Connect. Have a great rest of your day.